Okay, so looking at these angles, let's start with this intersection of these two lines right here. If that's 29 degrees, what does this angle here have to be? Supplement. That's a straight line across there, so those two have to add to 180. So 180 degrees minus 29 degrees is 151. So we get 151 degrees there. What's this angle over here have to be? 29. Has to be the same as this one, because these two are now supplements. They make a straight line. What's this one? 151. Good. Anytime two lines intersect, they're going to form four angles. Of those four angles, there will always be two equal pairs. The only exception will be is if they're all four the same. If they're all 90 degrees, then all four will be the same. Now, moving on from there, actually we can go down here. This intersection, since this line and this line were parallel, sounded a bit like Elmer Fudd there for a second, sorry. This intersection down here is predictable. What's this angle have to be? 29. Because this intersection and this intersection are going to be identical. So then this one, 151, this one, 29, and this one here, 151. Okay, so those are the ones we can predict there. Now back up here. If this angle is 73 degrees, what's this one here have to be? Well, this is a straight line again, right? So those two have to be supplementary. What's 180 minus 73? 107. So then this one has to be the three angles of a triangle have to add up to how much? 180. So 180 minus 107 minus another 29 is 44 degrees, correct? Make sense? So now if that's 44, what's this one have to be? That's a straight line, so 180 minus 44 makes 136. What's this one over here? $44. This one down here? 136. Very good. How about down here? What's this one have to be? 136. This one? 44. And of course, 136 and 44. And of course, up here, these lines intersect, so this one's 73. Has to be the same as the one across from it. This one's 107. So all those angles are findable from just the two that I gave you. Any questions on that? Okay, so then we also, one of the things we covered last week was variation. So if I tell you that y varies directly with x, and y is 42, then x is 14. Now I ask you to find y when x is 5. How are we going to start that out? Well, there's three steps here, three pieces of the puzzle we go through. The first step is this right here. What's that telling us? Y varies directly with x. So y equals a constant times x or divided by x? Directly is times. Our second piece of information here is a beginning value. We have values for both variables in a certain state. So we're going to put those values in to figure out what k is, what the constant is. What goes in for y? 42. Y is 42 when x is 14. So how do I find k? Divide by 14. Get k by itself. K is multiplied by 14. We divide by 14 to get it alone. 42 divided by 14 is 3. So k equals 3. So what does that tell us? Constant is 3, so our original equation, y equals k times x, is really y equals 3 times x. So now our third step, the actual question here, find y when x is 5. So now I just replace x with 5. So y equals 3 times 5, so y is 15. Now I might also tell you that y varies inversely with x. Y is 8 when x is 12. Find y when x is 4. So once again, here's my first piece of information. What's that telling us? Y equals constant times x or constant divided by x? Inversely means divided by. Constant divided by x. Second piece of information. Y is 8 when x is 12. So what's that mean? Replace y with 8, x with 12. Then, well, we're going to multiply by 12 first to find k. So 12 is gone. 8 times 12 is 96 equals k. So that's telling us that our relationship here, instead of y equals k times x, or k divided by x, is actually y equals 96 divided by x. And now the last step, find y when x is 4. Put 4 in for the x. What's 96 divided by 4? Y is 24. Any questions? Okay. We're going to talk about a couple of new topics here before we run out of time in the first hour. Most of the review here, we talked about this earlier in the course, area. And for a rectangle, which is mostly what we did, the area is simply the length times the width. Remember, we looked at those taking a single dot and stretching it to make those dimensions. So if we have a rectangle that is 12 inches long and 5 inches wide, its area is 12 inches by 5 inches, or 60 inches squared. The key there is those dimensions that we use for calculating area have to be perpendicular. They have to be at a right angle. The 12 times the 5. Because what we're thinking of is we're taking those 12-inch lengths, and if we think of that length as being a very, very thin rectangle like this, what we're doing is we're stacking those little rectangles up to make that area. Well, what if we didn't stack those rectangles straight up? What if it looked something like this? So this is still 12 inches long. The distance from here to here is still 5 inches. So all that means is those rectangles have been stacked not necessarily directly on top of each other now. Is it going to take any more or less rectangles to stack up to that 5-inch height? No, it's going to be the same number of them. And if we make sure they're the same width, they're all still 12 inches long, the area that that's going to cover is going to be exactly the same as the rectangle. Notice that once again, the 12 and the 5 are perpendicular. They form a right angle with each other. So the area there is still 12 inches times 5 inches, or 60 inches squared. We also have triangles that we can work on. So we're trying to find the area of a triangle, and I'm going to keep this 12 inches by 5 inches. The only thing we've learned how to find the area of so far is a rectangle. Well, this triangle is a part of a rectangle. So what we do is we draw it out like this. That's what we call the related rectangle. It's related to the triangle because we took that rectangle and we cut it in half to create the triangle. So the area of that related rectangle is still the 12 inches by 5 inches times 5 inches. The triangle is half of it, so it's just divided by 2. So the 12 times 5 is 60, divided by 2 is 30 inches squared again. Now the triangle does not have to be a right triangle like this one was. I could have a triangle like this. That's not a right angle up here. And let's say that this here is 20 feet down here. The related rectangle that contains that triangle would look like this. 20 feet would be the length, but we need to know the width. Well, the place on this triangle that would give us the width is from this point furthest away from the 20 down to the 20, and of course measured at a right angle. So let's say that I tell you that dimension is 7 feet. The area of this triangle here, again, notice the 7 and the 20 form a right angle, they're perpendicular. So the area of that rectangle would be 20 feet by 7 feet. And again, the triangle is half of that rectangle, so divided by 2. So 20 times 7 is 140, divided by 2 is 70 feet squared, or 70 square feet. Any questions so far? So as you can see, area is all about rectangles, and it's about taking two perpendicular dimensions. All area requires those two perpendicular dimensions. So let's look at something called a trapezoid. A trapezoid has two sides that are parallel and the other two sides that are not parallel. So it might look like this. So the two sides that are parallel are called bases. So this is a base and this is a base. And let's say that this top here is 12 inches. The bottom down here we're going to call 20 inches. And this distance between them, we'll say is 10 inches. All areas are related to rectangles. So we have to relate this to a rectangle somehow. If I come halfway down the side here and I cut this off, I flip that piece up, it will exactly fill that in and make that, the end of this will be squared off. I can do the same here. Come halfway down this side, cut this off here at a right angle, flip that off and flip that up, and I square off that end of the rectangle. So now I actually do have a rectangle. The width of that rectangle is just the 10 inches of height that we had before. The question is, what is the width? Well, we know that the width is actually somewhere between the 20 that goes all the way from here out to here and the 12, which is the shorter base. In fact, that width is exactly in between them. It is the average of the bases. So to average something, you add them together. 12 plus 20, and you divide by 2. So to find the area of a trapezoid, you average the bases, and then you multiply by that height. So 12 plus 20 is 32. 32 divided by 2 is 16, times 10 is 160. Those are in inches, so that is inches squared, or square inches. So a little bit of review of area. Next, we want to look at these right triangles. And if I give you that that's a right angle there, and that this side is 5 inches long and this side is 12 inches long, can I find the length of that third side? Well, the answer, of course, if I'm asking, is probably yes. Whenever we have a right triangle, of the three sides, two of them are what we call legs. Those two sides there are the legs because they make the right angle. They make the L of the triangle. The right angle, bless you. The right angle looks like an L, so those are the legs. The side that does not touch the right angle, it's across from the right angle, is called the hypotenuse. The hypotenuse will always be the longest side of the right triangle. So if I want to find that missing side here, there's a relationship. A squared plus b squared. The two legs has to equal c squared, the hypotenuse. So yes, a is 5, so 5 squared. B is 12, so 12 squared. That'll have to equal c squared. 5 squared is not 10, but 25. Very good. 12 squared, 144. Now I have to combine 12 and 144. 169 equals c squared. The last thing I have to do is square root. 13 equals c. So this side here is 13 inches long. One of the reasons we're putting this out here now, we're going to use it for other things as well, but if I give you a triangle, and I don't tell you if any of those angles are right angles, but I tell you the sides are 8 feet, 15 feet, and 17 feet. I need to be able to tell if that is a right triangle or not. If this were a right triangle, what angle would have to be the right angle? A, B, or C? C. Why would it be C? Well, it's the biggest one visually, but it's also between the two shortest sides, right? Remember, the longest side, the hypotenuse would always be the longest side. So if this is a right triangle, the 17 would have to be the hypotenuse. So the right angle has to be between the two shorter sides. Now, we don't know if that's a right angle yet or not. We're going to put a question mark there. So we're going to call this A and B, and this C, because if it's a right triangle, that's how they would have to be labeled. So let's fill this in. A is 8, so 8 squared. B is 15, so 15 squared. I'm not going to put an equal sign here. I'm going to put a question mark. Because I don't know if they equal yet or not. I don't know if that's a right angle. 8 squared is 64. 15 squared is 225, which adds up to 289. Over here, what's 17 squared? It's 289. Those are equal, so this is a right angle, so this is a right triangle. So to find its area, it's going to be 8 feet times 15 feet, or 15 times 8, either way, divided by 2. So that is 60 feet squared, or 60 square feet. Any questions? Another reason why we're looking at that is because we're going to talk briefly about perimeter. Perimeter is the distance around an object. So for a rectangle, if I have sides of 5 inches and 12 inches, the perimeter is just going to be 5 inches plus 12 inches plus, how long does this side have to be? 5 inches, because it's got to be the same as the opposite side. And this one has to be 12 inches. I just add up all of the sides. That adds up to 34 inches. Notice it's just inches, because when I add, I keep the same name. For areas, it was square inches, or inches squared, or feet squared, because I'm multiplying. I combine the names. So to find the perimeter of this triangle, I need to know that side, don't I? Well, to find that side, those are A and B. This is going to be C. So 11 squared plus 60 squared equals C squared. 11 squared is 121. 60 squared is 3,600. That adds up to be 3,721 equals C squared. And of course, we need to square root. That's 61. That side's 61. Now we can find the perimeter. It's 11 inches 60 inches plus 61 inches, which is 132 inches of perimeter. Any questions? Okay, we're out of time for the first hour, but this material will be found in page 408 of your book, exercise 12.2, and on page 415, exercise 12.3. So let's go ahead, we'll take a 10-minute break. At 3:30, we'll come back and get the rest of our material.